In this tutorial, we're taking a look at Com.2. I can analyze the slope and y-intercept for a line of best fit to explain a scientific relationship. So the first thing we need to do is calculate slope. To do that, I want to pick 2 points on my line of best fit. They do not have to be data points. They just have to be points on your line of best fit. So I'm going to pick 2 points where it seems like it crosses over. It's really easy to see where those points are. So this looks like it's at an intersection here, and this one looks like it's at an intersection here. Notice that those are not the exact data points. That's okay as long as they're on the line of best fit. So this data point here would be 1, 2, and this data point here would be 4, 8. Now we have our little reminder over here. To calculate slope, we need the change in y over change in x. So the change in y is 8 minus 2, and that is milliliters. So it's 6 milliliters over our change in x is 4 minus 1 grams. So 3 grams. And we're going to go ahead and simplify that. And 6 over 3 milliliters for every gram is the same thing as 2 milliliters for every 1 gram. I'll fit that on the page here. So we got 2 milliliters for every 1 gram. And that is the inverse of density there, but we don't need to worry about that for our purposes. So that there is my slope. So if I was going to write a for every statement, I would write for every 1 gram of mass, there are 2 milliliters of volume. Now, if I was going to write my equation, remember my equation in my line is y equals mx plus b. So I'm going to replace y with volume. Well, erase that, it's a little easier to see there. Remember, this is my y here. So instead of writing y, I'm going to write volume equals m. Remember, m is my slope, so I'm going to take that 2 milliliters for every 1 gram. Don't forget those units, they are important. Times x, remember your x is down here. That's your mass. Plus b, your y-intercept. In this case, our y-intercept is 0, so we don't have to write anything. So the equation of my line would be volume equals 2 milliliters for every 1 gram times the mass. And I could use that to predict anything that's off my graph. And there you have it.